As you settle into peaceful rest tonight, look up through the darkness toward the stars and know that you live in a solar system filled with countless rocky wanderers, asteroids, remnants from the birth of our planetary family 4.5 billion years ago, drifting through space in elegant orbits that occasionally bring them close to Earth. This might sound alarming, but tonight you'll discover why you can rest peacefully, protected by cosmic mathematics, gravitational choreography, and an increasingly sophisticated network of human vigilance that watches the skies on your behalf. The word asteroid means star-like, given by early astronomers who noticed these objects looked like distant stars through their telescopes, though they moved against the background of fixed constellations. But asteroids are not stars at all. They are the leftover building materials from the formation of our solar system. Rocky fragments that never quite assembled themselves into a planet, floating in stable orbits that have remained largely unchanged for billions of years. Most asteroids orbit the Sun in a vast belt between Mars and Jupiter, kept from forming a planet by Jupiter's immense gravitational influence. This main asteroid belt contains millions of rocky bodies, ranging from tiny pebbles to Ceres, a dwarf planet nearly 600 miles in diameter. Despite Hollywood's depictions of densely packed asteroid fields, the reality is far more peaceful. The space between asteroids is so vast that if you stood on one asteroid, you likely wouldn't be able to see another with the naked eye. The asteroids that occasionally venture into Earth's neighborhood, called near-Earth asteroids, follow orbital paths that bring them within 30 million miles of our planet, close in cosmic terms but still representing vast distances by human standards. Scientists have identified over 30,000 of these near-Earth objects so far, and they discover dozens more each week using increasingly sophisticated detection systems that scan the skies continuously. Here's the comforting truth that should help you rest easily tonight. Earth has been dancing through this cosmic shooting gallery for over 4 billion years, and life has thrived for most of that time. The orbits of asteroids are governed by precise mathematical laws that make their paths predictable and, in most cases, completely safe. The solar system is so incomprehensibly vast that even with millions of asteroids, the probability of any specific one hitting Earth on any given night, including tonight, approaches 0. Your peaceful rest tonight occurs within a bubble of gravitational protection. The Moon, with its substantial mass, has absorbed countless asteroid impacts that might otherwise have struck Earth, its cratered face bearing witness to billions of years of cosmic collisions. Jupiter, with its enormous gravitational field, acts like a cosmic vacuum cleaner, capturing or deflecting many asteroids and comets that might otherwise venture into the inner solar system where Earth orbits. The asteroid that ended the age of dinosaurs 66 million years ago was roughly 6 miles in diameter, a mountain-sized rock traveling at 45,000 miles per hour when it struck what is now Mexico's Yucatan Peninsula. The energy released was equivalent to billions of atomic bombs, creating a global catastrophe that changed the course of evolution on Earth. Yet here's the remarkable truth. Asteroids of that size strike Earth roughly once every 100 million years, making such events extraordinarily rare on human timescales. Modern astronomy has cataloged over 95% of the asteroids larger than 1 kilometer in diameter that could potentially approach Earth, and none of them pose any threat for at least the next century. The remaining 5% will be discovered and tracked long before they could pose any danger. giving humanity decades or even centuries of advance warning should any intervention ever become necessary. Tonight, as you drift toward sleep, you are protected not only by the vast emptiness of space and the mathematical precision of orbital mechanics, but also by a global network of telescopes, radar systems, and dedicated astronomers who spend their nights watching the cosmic neighborhood, ensuring that no asteroid approaches without our knowledge. You can rest peacefully, knowing that Earth is far safer from asteroid impacts now than at any previous time in human history. The cosmic census, how we track potential threats. Imagine now the remarkable global effort underway to map and monitor every rocky visitor that ventures near Earth's orbit. A cosmic census that grows more complete each year, transforming asteroid threats from unknown dangers into precisely tracked, well-understood objects, whose future positions we can predict with extraordinary accuracy. The Catalina Sky Survey in Arizona, the Pan-STARRS telescopes in Hawaii, the ATLAS system that scans the entire visible sky multiple times each night. These and dozens of other facilities around the world work tirelessly to detect asteroids that might pose any future threat to our planet. Every clear night, these automated systems photograph millions of stars, then use sophisticated software to identify any points of light that move between images, revealing asteroids by their motion against the background of stationary stars. When astronomers discover a new near-Earth asteroid, they immediately begin the process of determining its orbit with increasing precision. Multiple observations over days, weeks, and months allow orbital calculations to become more accurate, revealing whether the asteroid will ever come dangerously close to Earth, or whether its path will keep it safely distant for centuries to come. This process transforms an unknown object into a completely characterized neighbor, whose future positions can be predicted as accurately as planetary motions. NASA's Center for Near-Earth Object Studies maintains a constantly updated database of every known asteroid and its orbital characteristics. This Jet Propulsion Laboratory facility calculates the future positions of all near-Earth asteroids, identifying any that might approach Earth closely enough to require further monitoring. Their sophisticated models account for gravitational influences from all major planets, solar radiation pressure, and even the subtle effects of heat radiating from the asteroids themselves. The current state of this cosmic census is remarkably reassuring. Scientists have discovered and tracked over 95% of asteroids larger than 1 kilometer in diameter, the size that could cause global catastrophe if one struck Earth. None of these large asteroids poses any threat for at least the next century, and most will remain safely distant for millennia to come. The remaining unknown asteroids in this size range, if any exist at all, will almost certainly be discovered long before they could pose any danger. For smaller asteroids in the 140-meter size range, large enough to cause regional devastation but not global catastrophe, scientists have cataloged roughly 40% so far, with new discoveries added continuously. Even in the unlikely event that one of these undiscovered asteroids were on a collision course with Earth, the odds of it striking a populated area are remarkably low, given that oceans cover 71% of Earth's surface and vast regions of land remain uninhabited. The detection systems continue to improve each year. New telescope facilities come online. Existing systems upgrade their cameras and software, and international cooperation ensures that asteroid tracking operates continuously around the globe. An asteroid discovered rising in the east by telescopes in Australia can be tracked throughout the night by observatories in Asia, Africa, Europe, and finally the Americas as Earth's rotation brings different longitudes into darkness. Radar observations from facilities like the Goldstone Solar System Radar in California and the Arecibo Observatory before its collapse, and now the Green Bank Telescope, provide incredibly detailed information about asteroid size, shape, rotation, and surface characteristics. These radar measurements can determine an asteroid's position to within a few meters and reveal surface features as small as a few feet across, providing data that refines orbital predictions and helps scientists understand asteroid composition and structure. The mathematical precision of orbital mechanics means that once an asteroid's orbit is well determined, scientists can predict its position decades or even centuries into the future with extraordinary accuracy. The gravitational influences that shape asteroid orbits are completely understood and predictable, making future close approaches calculable with precision that would have seemed miraculous to previous generations. This growing catalog of near-Earth asteroids reveals a solar system that is far more ordered and predictable than random. Most asteroids follow stable orbits that keep them far from Earth indefinitely. The few that do approach our planet closely do so on predictable schedules, returning to Earth's vicinity at regular intervals that can be calculated centuries in advance. There are no surprises lurking in the dark, no unknown threats suddenly appearing without warning. Only the gradual completion of a census that grows more reassuring with each new discovery. As you rest tonight, feel comforted by this global network of cosmic guardians watching the skies on your behalf, cataloging every rocky visitor, calculating every future trajectory, ensuring that humanity will never again be surprised by an asteroid impact. The ancient fear of rocks falling from the sky has been transformed into a modern confidence based on systematic observation, mathematical precision, and the reassuring knowledge that we are watched over by both the natural protection of cosmic probabilities and the vigilant attention of human science. The mathematics of safety. Why space is mostly empty. Rest now in contemplation of the remarkable emptiness of space, where the vast distances between objects create a cosmic environment far safer than our Hollywood-influenced imagination might suggest, where mathematical probability reveals that Earth occupies a tiny target in an incomprehensibly large shooting gallery. Picture Earth as a tiny blue marble, floating in a cosmic ocean so vast that if you shrank the sun to the size of a beach ball, Earth would be a peppercorn orbiting 26 feet away, and the nearest asteroid large enough to cause serious damage would likely be miles distant. This is the true scale of the solar system, mostly empty space with tiny rocky islands separated by distances that make collisions extraordinarily improbable. The mathematics of orbital mechanics provides profound reassurance about Earth's cosmic safety. An asteroid must satisfy multiple unlikely conditions simultaneously to strike our planet. It must be in an orbit that crosses Earth's orbital path. It must arrive at the crossing point at precisely the same moment that Earth is there, which happens only during a tiny window given Earth's orbital speed of 67,000 miles per hour. And it must survive any close encounters with the moon's gravity that might deflect its trajectory at the last moment. Consider the scale of the target Earth presents to incoming asteroids. Our planet's cross-sectional area is roughly 50 million square miles, which sounds enormous until you calculate the area of the spherical shell that represents Earth's orbit around the Sun. That orbital shell has an area of roughly 280 billion square miles, making Earth's cross-section just 0.00000000018% of its orbital area. An asteroid traveling through Earth's orbital region has only the tiniest chance of hitting our planet, rather than passing harmlessly through empty space. Even for asteroids in orbits that cross Earth's path, collision probability remains reassuringly low. Most near-Earth asteroids take decades or centuries to return to Earth's vicinity, and during each passage, the probability of actual collision is typically less than 1 in a million. Over longer timescales, some asteroids will eventually strike Earth, but eventually usually means millions or tens of millions of years in the future, far beyond any relevant human timescale. The Torino scale, developed by scientists to communicate asteroid impact hazard to the public, ranges from 0 to 10. 0 means no hazard at all. The asteroid will definitely miss Earth, or is too small to cause damage. 10 means a certain collision, capable of global catastrophe. Reassuringly, every known asteroid currently ranks at 0 on this scale, except for a handful rated at 1, which means events having no likely consequences that merit routine monitoring, but pose no actual threat. Astronomers continuously calculate what they call impact probability for all known near-Earth asteroids, the mathematical chance that the asteroid will strike Earth during its next close approach, or any future approach within the next century. For the vast majority of known asteroids, this impact probability is precisely 0. Their orbits are well characterized enough to guarantee they will miss Earth by comfortable margins during all predicted future encounters. For the tiny minority of asteroids where some uncertainty exists about future trajectories, impact probabilities typically range from 1 in several thousand to 1 in several million. Odds so low that you face far greater risks from everyday activities than from any asteroid strike. You are more likely to be struck by lightning multiple times than to be affected by an asteroid impact during your lifetime. The gravitational architecture of the solar system provides natural protection against many potential impactors. Jupiter's immense mass shepherds asteroids into stable orbits, while close encounters with planets can deflect asteroids onto safer trajectories or accelerate them out of the inner solar system entirely. Mars and Venus also contribute to this gravitational choreography, creating a dynamic system where most potentially hazardous orbits gradually evolve towards safer configurations over millions of years. Even the asteroids that do occasionally strike Earth are mostly harmless. Small asteroids entering Earth's atmosphere at tens of thousands of miles per hour experience enormous friction that heats them to incandescence and breaks them apart in the upper atmosphere. The brilliant shooting stars you've seen on clear nights are typically caused by particles no larger than grains of sand, burning up 50 to 70 miles above Earth's surface, where they pose no threat to anyone below. Larger asteroids that survive atmospheric entry, delivering meteorites to Earth's surface, are remarkably rare, and the probability that any particular meteorite fall will strike a populated area is vanishingly small. No one in recorded history has been killed by a meteorite strike, and only a handful of people have ever been hit by falling space rocks, and those encounters caused only minor injuries. Your house is statistically more likely to be struck by lightning than by a meteorite. The Chelyabinsk meteor that exploded over Russia in 2013, injuring over 1,000 people primarily from broken glass caused by the shock wave, was roughly 20 meters in diameter, large enough to create a spectacular airburst, but too small to have been detected by current survey systems before its arrival. Yet even this unexpected visitor demonstrated Earth's atmospheric protection. The rock disintegrated completely at high altitude, with no fragments reaching the ground traveling at cosmic velocities. As you drift towards sleep tonight, rest in the mathematical certainty that space is vast, asteroids are rare, and Earth is tiny. The probability that any asteroid will strike our planet on any given night approaches zero so closely that the number would require dozens of zeros after the decimal point before reaching any significant digits. You are protected by emptiness, by gravity, by atmosphere, and by the fundamental mathematics of orbital mechanics that make collisions so supremely unlikely that you can sleep without any concern for rocks falling from the sky. Earth's defense systems, natural and human protection. Feel yourself now protected by multiple layers of cosmic defense, both natural and increasingly technological, that shield Earth from asteroid impacts and provide humanity with the tools to prevent any future collision that might threaten our civilization. Earth's atmosphere provides the first line of defense against space rocks, a protective blanket of air that extends roughly 60 miles above your resting body. Small asteroids entering this atmospheric shield at velocities of 25,000 to 160,000 miles per hour experience incredible friction that heats them to thousands of degrees, causing them to vaporize completely before reaching the ground. This atmospheric ablation protects Earth from countless small impacts every day, turning potential threats into harmless shooting stars that add their cosmic dust to our planet's atmosphere. The moon serves as Earth's ancient bodyguard, its cratered face bearing witness to billions of years of asteroid impacts that might otherwise have struck our planet. Luna's substantial mass, 1/81st of Earth's mass, creates gravitational influences that occasionally deflect incoming asteroids onto safer trajectories. While the moon is not large enough to provide complete protection, its presence has certainly prevented some impacts throughout Earth's history and continues to offer probabilistic shielding today. Jupiter, the solar system's giant protector, plays an even more significant role in Earth's defense. With 318 times Earth's mass and a gravitational influence that extends throughout the solar system, Jupiter captures or deflects many comets and asteroids that might otherwise venture into the inner solar system where Earth orbits. The collision of comet Shoemaker-Levy 9 with Jupiter in 1994 provided a spectacular demonstration of this protective role, as fragments of the comet struck Jupiter's atmosphere, creating Earth-sized impact scars that persisted for months. Beyond these natural defenses, humanity has developed increasingly sophisticated technological systems for asteroid detection and deflection. The Double Asteroid Redirection Test, DART mission, which successfully struck the asteroid Dimorphos in 2022, demonstrated that humans can now alter asteroid orbits using kinetic impactors. Spacecraft deliberately crashed into asteroids at high velocity to change their trajectories through momentum transfer. The DART mission's success was profound and reassuring. The spacecraft struck Dimorphos at 14,000 miles per hour, changing the asteroid's orbital period by more than 30 minutes, far more than scientists had predicted as the minimum successful outcome. This demonstrated that deflection technology works even better than expected, and that humanity now possesses proven capability to protect Earth from future asteroid threats, should any be discovered. Other deflection concepts exist beyond kinetic impactors. Gravity tractors, spacecraft that would hover near an asteroid for months or years, using their tiny gravitational attraction to slowly tug the asteroid onto a safer trajectory, offer a gentler deflection method for smaller asteroids with decades of warning time. Nuclear standoff detonations, where nuclear devices explode near an asteroid without directly impacting it, could push large asteroids off collision courses through the force of the explosion. Scientists emphasize that decades of warning time would be required for any deflection mission, but current detection capabilities provide exactly that. The continuous survey of near-Earth asteroids means that any significant threat would be discovered decades or even centuries before potential impact, providing ample time to design, build, launch, and execute deflection missions, with multiple backup attempts if needed. International cooperation ensures that asteroid defense benefits all humanity. The United Nations established the International Asteroid Warning Network to coordinate global detection efforts, while the Space Mission Planning Advisory Group brings together space agencies from around the world to plan potential deflection missions. No single nation guards Earth. The entire global community shares responsibility for protecting our common home. The Planetary Defense Coordination Office at NASA serves as the organizational hub for American asteroid detection and deflection efforts, coordinating observations, calculating impact probabilities, and planning potential response missions. Similar organizations exist in Europe, Japan, Russia, and China, creating a global network dedicated to ensuring that no asteroid impact surprises humanity. Ground-based radar systems and spacecraft missions continue to improve our knowledge of asteroid characteristics, their composition, structure, rotation rates, and surface properties. This information is crucial for designing effective deflection strategies, as different asteroid types require different approaches. A solid iron asteroid requires different deflection techniques than a loose rubble pile, held together primarily by gravity. Future space missions will continue testing deflection technologies and studying asteroid properties. The European Space Agency's Hera mission will revisit the Dimorphos asteroid system to study the crater created by DART's impact and precisely measure the momentum change, providing valuable data for future deflection planning. China and other space agencies have announced their own asteroid deflection test missions, building global capability and redundancy into Earth's defense systems. Even private space companies contribute to asteroid defense, as the technologies developed for asteroid mining missions, identifying, approaching, and potentially manipulating asteroids, provide capabilities that could be adapted for deflection purposes if needed. The growing human presence in space creates multiple pathways for protecting Earth from future impacts. As you rest peacefully tonight, you are protected by atmospheric ablation, lunar and Jovian gravitational influences, global detection networks, proven deflection technologies, international cooperation, and growing space capabilities. Earth is better defended against asteroid impacts now than at any time in planetary history, and that protection grows stronger each year as technology advances and human civilization expands into the solar system. Sleep knowing that if any asteroid ever threatens Earth in the future, humanity will see it coming decades in advance and possesses multiple proven methods for changing its trajectory, ensuring that your children and grandchildren and all future generations will live in a world protected not just by natural cosmic defenses, but by human ingenuity, technological capability, and the collective determination to safeguard our precious planetary home. The impact that changed everything. Learning from deep time. Journey now through deep time to understand how asteroid impacts have shaped Earth's history, not as constant catastrophes, but as rare punctuation marks in billions of years of relative calm. Events so infrequent that civilizations can rise and flourish for millennia without experiencing anything more dramatic than occasional meteor showers and harmless shooting stars. The Chicxulub impact 66 million years ago, the asteroid that ended the Cretaceous period and the reign of dinosaurs, represents the most significant impact event in the history of complex life on Earth. The 6-mile-wide asteroid struck the Yucatan Peninsula with the energy of billions of nuclear weapons, creating a crater 110 miles in diameter, triggering mega tsunamis, igniting global wildfires, and lofting enough dust into the atmosphere to block sunlight for years, causing global cooling and the extinction of roughly 75% of all species on Earth. Yet, here's the perspective that should help you rest easy tonight. Impacts of this magnitude occur only once every 50 to 100 million years on average. The entire span of human civilization, from the first agricultural settlements to modern cities, represents only about 12,000 years, roughly 1/10,000th of the interval between civilization-ending impacts. Recorded human history covers perhaps 5,000 years, making even this tiny fraction of the time between catastrophic strikes. Since the Chicxulub impact, Earth has experienced 66 million years of relative quiet, while smaller impacts have occurred, creating craters, occasionally causing regional devastation. None has approached the scale necessary to threaten complex life across the planet. The very fact that mammals could evolve from small, shrew-like creatures into the incredible diversity of species we see today, including humans, demonstrates the profound stability of Earth's cosmic environment over evolutionary timescales. The Tunguska event of 1908 in Siberia represents the largest asteroid impact in recorded human history. An asteroid, roughly 120 feet in diameter, exploded in the atmosphere, flattening 800 square miles of forest, but causing no human casualties due to the remote location. Events of this magnitude occur roughly once per century on average, yet the vast majority strike ocean or unpopulated land, causing no harm to human civilization. The geological record reveals roughly 190 confirmed impact craters on Earth's surface, ranging from small bowl-shaped depressions to massive ancient scars, mostly erased by erosion and geological processes. This might sound like a lot, until you consider that these craters accumulated over billions of years, an average of one preserved crater per 20 million years. And most craters represent relatively small impacts that caused only local effects. The Barringer meteor crater in Arizona, nearly a mile in diameter and 550 feet deep, was created roughly 50,000 years ago by an iron asteroid about 150 feet in diameter. This impact released energy equivalent to 10 megatons of TNT, yet its effects were confined to a relatively small area. Even standing at the crater's rim, you can see that the surrounding landscape remained relatively undisturbed beyond a radius of a few miles. Impacts of this scale occur roughly once per several thousand years on average, and again, most strike unpopulated areas. Earth's geological activity, plate tectonics, erosion, volcanic resurfacing, erases most impact evidence over time, making Earth's surface appear far less cratered than the Moon or Mars, where ancient impacts remain preserved for billions of years. This means Earth has certainly been struck more often than the 190 confirmed craters suggest,
Yet life has persisted and thrived throughout nearly 4 billion years of bombardment, demonstrating the resilience of biology even in a solar system that occasionally delivers cosmic impacts. The late heavy bombardment, a period roughly 4 billion years ago when the inner solar system experienced intense asteroid impacts, occurred long before complex life evolved on Earth. By the time multicellular organisms appeared, the impact rate had decreased to approximately the current level and has remained relatively stable since. You live in a solar system that has already passed through its most violent phase, where impact rates are lower than at any time in the past 4 billion years.
Scientists study impact craters not primarily as warnings of future catastrophe, but as windows into Earth's deep history. Impact sites preserve geological evidence of past climate, atmospheric composition, and the evolution of life. The Chicxulub crater helped scientists understand the end Cretaceous extinction, while other impact sites provide insights into how life recovers and diversifies after catastrophic events. The impact threat that concerns scientists most is not the extremely rare civilization-ending asteroid, but the more common regional-scale impactors in the 100 to 300 meter size range. Yet even here, the mathematics of probability provides reassurance. These objects strike Earth roughly once per several thousand years on average, and with 71% of Earth's surface covered by ocean and vast land areas remaining uninhabited, the probability that any particular impact would strike a populated area remains reassuringly low. Historical records contain no verified accounts of anyone being killed by an asteroid impact, despite thousands of years of written history covering billions of human lives. The statistical analysis is clear. You face far greater risks from automobile accidents, lightning strikes, or countless other everyday hazards than from asteroid impacts. The cosmic threat exists in probability, but not in practical concern for any individual human lifetime. As you drift towards sleep, rest in the knowledge that Earth's deep history reveals a planet that has been a safe haven for life, despite occasional asteroid impacts, where impacts large enough to cause global catastrophe occur so rarely that entire civilizations can rise and fall without ever experiencing one, where the mathematical probability of any significant impact during your lifetime approaches zero, so closely that it deserves no space in your thoughts or concerns. The dinosaurs, those magnificent creatures whose 165 million year reign ended in cosmic catastrophe, remind us that life is resilient, that evolution continues even after the most devastating events, and that the rarity of truly catastrophic impacts has allowed complex life to flourish on Earth for over 500 million years, creating the beautiful living world you inhabit, and the consciousness that allows you to contemplate these cosmic timescales as you peacefully drift toward sleep. The cosmic perspective, living confidently under the stars. Rest now in the profound perspective that comes from understanding your place in a solar system that is simultaneously dynamic and remarkably stable, where asteroid impacts represent not an ever-present danger, but one of the least concerning risks you face in your daily life, far overshadowed by the actual challenges and opportunities that deserve your attention and concern. The statistical reality is unambiguous and reassuring. Your probability of being affected by an asteroid impact during your lifetime is far lower than being struck by lightning, winning the lottery, or experiencing countless other extremely unlikely events. NASA's careful analysis of all known asteroid threats shows that the cumulative risk of death from asteroid impact for any individual during a human lifetime is roughly 1 in 75,000. And this already tiny number continues to decrease as detection systems improve and unknown asteroids are discovered and confirmed to be harmless. To put this in perspective, you face greater statistical risk from bee stings, fireworks accidents, or being struck by a falling coconut than from asteroid impacts. The attention that asteroid threats receive in popular culture far exceeds their actual risk level, creating a perception of danger that exists more in imagination than in mathematical reality. Your ancestors lived for hundreds of thousands of years without any knowledge of asteroids, without telescopes to detect them or mathematical models to predict their orbits. And yet, humanity thrived and expanded across the planet. Now, in the modern era, you possess knowledge and capabilities your ancestors never dreamed of. The ability to see cosmic threats coming decades in advance, to calculate their trajectories with precision, and to alter those trajectories if needed. The development of asteroid detection and deflection capabilities represents one of humanity's most remarkable achievements. The first time in Earth's 4 billion year history that the planet harbors a species capable of protecting itself and all other life from cosmic impacts. Your generation lives during this transition from passive vulnerability to active planetary defense, a milestone in the evolution of intelligence and civilization. This doesn't mean you should fear asteroids more, but rather that you can worry about them less. The same scientific advances that revealed asteroid threats have also provided the tools to manage those threats, creating a situation where informed awareness replaces ancient fear, and rational probability assessment replaces apocalyptic anxiety. The small asteroids that frequently enter Earth's atmosphere, creating meteor showers, occasional fireballs, and harmless meteorite falls, remind us that we live in a solar system, not in isolation, connected to the cosmic environment through gravity, light, and the occasional visitor from deep space. These small events are not threats, but rather gentle reminders of our cosmic context, opportunities to appreciate the dynamic nature of the solar system while remaining protected by atmosphere, distance, and the fundamental mathematics of orbital mechanics. Future generations will likely view asteroid defense the way you view weather forecasting, a routine application of scientific understanding to manage natural phenomena, providing advance warning and enabling appropriate responses when needed. Just as weather forecasting allows you to carry an umbrella on days when rain is likely, asteroid tracking ensures that humanity will never be surprised by an impact and will have decades to prepare deflection missions if any future threat is discovered. The search for near-Earth asteroids also provides valuable scientific knowledge beyond planetary defense. These ancient rocks represent pristine samples from the early solar system, unchanged since the planets formed. Studying asteroids helps scientists understand how Earth and other planets assembled from the primordial disk of dust and gas that surrounded the young sun. Some asteroids may have delivered the water that fills Earth's oceans and the organic molecules that became the building blocks of life. Future asteroid missions, both robotic and eventually human, will treat these space rocks not as threats, but as resources and destinations. Asteroids contain valuable metals, water that could support space exploration, and scientific secrets about the formation of the solar system. What began as planetary defense has evolved into a broader program of asteroid exploration that may eventually support human expansion into the solar system. The The cosmic perspective on asteroids reveals a universe that operates according to mathematical laws we can understand and predict, where apparent chaos resolves into ordered motion when viewed from the right perspective, where threats that seem immediate to imagination are revealed by science to be manageable, rare, and increasingly well understood. As you sleep tonight, under the same stars that have watched over Earth for billions of years, rest in confidence that you are safer from cosmic impacts now than at any previous time in planetary history. The universe that seems threatening in science fiction stories is actually a remarkably orderly place where catastrophic events are rare enough that life has flourished for billions of years, where human intelligence has developed the tools to detect and prevent future threats, and where the cosmic environment that created you also protects you through the vastness of space, the mathematics of probability, and the growing capability of human science and technology. Your dreams tonight will unfold beneath countless stars and asteroids, all following their appointed paths through space, according to laws that make your world safe, predictable, and ultimately hospitable to the miracle of consciousness that allows you to contemplate these cosmic wonders before drifting peacefully into sleep, protected by space, by science, and by the fundamental physics that make Earth a safe harbor for life in the cosmic ocean. Sleep well, cosmic citizen, knowing that the asteroid threat exists primarily in distant future timescales and statistical abstractions, not in the comfortable reality of your peaceful present, where the stars above watch over you, not with menace, but with the same ancient light that has guided and inspired humanity throughout our entire existence on this precious, well-protected planet we call home.